Welcome to this tutorial on Qcaid's high-precision backtest. In previous videos, you've seen how to create and optimize a strategy, and now I will show you how to run a high-precision backtest and tell you about its features and advantages. Once we have identified optimal parameters for a strategy, we can further validate it by running a high-precision backtest. We will once again use the strategy we designed and tested in other videos. Running a high-precision backtest is very similar to running a standard backtest. Click on the Upload the Strategy to Backtest icon and select the option Precise Backtest. This backtest requires more calculation time than a standard backtest, so we will configure it for a shorter time period. In this case, we will use 1 week. The instrument selection window will list all the available instruments with the necessary depth of data to run this kind of backtest. We'll set the variables to the chosen values from the previous optimization process. Using the precision backtest for optimization is not recommended because of the longer computing time requirements as compared to a standard backtest. Press Finish and confirm the execution. We will also launch a standard backtest over the same time period to compare the results. Choose a different name, leave the same time period, and select the same instrument. With the same parameters for execution, we click Finish and Confirm. To see the backtest results, we click the Open Report Window button. There, we can find the 2 backtests we've launched. Due to the short time period we have assigned to the standard backtest, it will complete almost immediately. The precise backtest, identified by this symbol, requires a longer time. While performing a precision backtest, the process will recreate the order book as it happened in the market during the selected dates. This is achieved by processing the order book information provided by the market with at least 5 levels of bid and ask prices. By introducing the orders of our strategy inside the book that is being rebuilt, we manage to reproduce the impact of our orders on the book and get results that take into account the priority of the order and the available volume in each price level. Since the process is performed on a central server, we need not worry about the collection, management, and processing of the large volume of data required to perform this type of backtest. Now that both backtests have been completed, we can compare the results. We open both backtest results that appear in separate tabs, and we can place them freely so as to compare the results in an easy way. We can see that the performance during the simulated period is similar, but with slight variations. A net profit of -35.40 in the standard backtest versus a net profit of -35.70 in the precise backtest. If you compare the orders, we can see there's no important difference between them. The benefits of this kind of simulation are more apparent in strategies that are more sensitive to parameters such as available volume. Here is a sample strategy. This strategy works as a custom limit order. It uses the bid and ask price information, the spread, to acquire a large volume of contracts, at this example 100,000. We run the backtest as in the previous examples. Choose the precision backtest mode and give the backtest a name. Then we select the time period. We'll use only 3 days to make it faster. Next, we select the instrument and we configure the maximum price. We finish and confirm. Now we open the report window and wait for it to finish. This strategy will keep a limit order alive as long as the position held is lesser than the desired quantity. The quantity and price of the order will be adjusted dynamically. The quantity will be equal to the remaining amount to complete our position. As for the price, as long as the ask price is lower than our maximum price, we'll try to fill the order at the billed price. If the ask price ever reaches our maximum price, we'll set the order to the ask price so that it fills quickly. We see that the backtest has completed, and we can now see the results. In this case, we're interested in seeing the details of the order's execution. Orders are created at a value below our limit price and are modified as the price changes. At certain times, the system is capable of reproducing partial fills. If the price changes before the execution is completed, the remaining part is modified to maintain the remaining volume at the new price. You will notice how an order receives several partial fills until completing its full quantity. As you can see, this backtest manages to reproduce the behavior of orders in the real market with maximum precision. I will be with you again in the next video to show you how to run a strategy both on a simulated market and on the real exchange. Thank you for watching.